This video belongs to the class Engineering Technology 196 Advanced Workbenches from the Everett Community College in Washington, state of Washington. My name is Amilcar Ramirez, and I'm going to demonstrate how to ensemble this engine and put all the parts together and simulate the engine in movement. Do a simulation of the different parts moving accordingly based on on the parameters that we are going to pre-assign to each one of them. We will start by defining well, the parts have to be built in advance. Once the part are built with the part design with this app that I'm going to show you right now. Part Designs is the app we use for the building of the parts, all the different parts, different techniques. Once the parts are designed, we put them together with a assembly design. We do copy all the parts and we put them all together. The little yellow sign by the part means that the parts have been moved. So the first thing that we have to do is to make sure that the main part where all the different, the main block, which is in case this part in here, I'm putting the cursor, my mouse. The first thing we have to make sure is that the part is in zero position, 0, 0, 0 in terms of the axis, and it's fixed. So the way to check that out, you can do the assembly with the parts in another position, but it's better to have it in 0 so you are in control of the different locations. You go to property, and in property we make sure that in position that the part is in 0, 0, 0. There's no translation of the part. So once you have that, you go and you start your assembly. The first thing you do is to go to assembly and you make sure that the part is fixed. So the way you do it is you go here and you click on fix on engineering connection, click on fix on the part, and then that will be the first engineering connection that you will basically do. You save that. There is a little red dot that will disappear once the part is saved. Second thing that we do is to get rid of the rest of the parts so they won't be in the middle. We hide them and we start doing the assembly of the parts, starting with the crankshaft. We want to move the crankshaft from the current location to the 0 position where the block is located. So we made them concentric, and normally you want 2 bondings on every connection, so the attachments will be solid and you won't have any movement whatsoever. The way to verify that the attachments are done is by checking the position in engineering connection. So the second attachment we are going to do is so we already did the rotational attachment. The second will be the face. We wanna face this part of the crankshaft with this plane and the block. So that's the second attachment. We as I said, we make sure we verify that the connections are properly done. Double click on engineering design and we check that the part, as you can see, we've got the axis with the revolute and an axis and edge with the revolute, and we have the face and plane, which is a contact. So we say yes, And here when it asks me if I want this specification uh, uh, to be checked, I put no. I could put yes, but if I want to do any changes, I can actually do it at the end. I don't necessarily need to do it now. So I put no, and it will put me here. This location is well, because it just asked me for a new position. I don't want that, so I close it here, and this is basically the part. You can see it will show you here the coincide and the contact. So that done, we update it, and the little dot will disappear. Once we have that contact, we want to make sure that the that we're gonna add to the we're gonna root enrich this connection with a uh, rotational command. And the way to do that is to select the plane that we want to rotate, and we want an angle, just like this one here. We want an angle together with this other plane that we are selecting. The angle has been created. It's a command, and we're gonna have this little check mark that shows on the mouse. We double click, and once you do that, the connection, the initial connection has been enriched. Then we go back here, and we want to make that angle connection that we have created, we want to make it control. So control by the motor that we're going to attach to this connection. So we change from driving to control, and it will tell you that do you wish to release the rigid connection? You say yes, and then that's done. We okay, and we update what we just did. Once we do that, we want to verify that the connection is rotational and is functional. In order to do that, we the go to here to mechanical system design, and we create a, a mechanical system uh, um, preparation, and we name it like let's name it in Spanish, proyecto motor. Once we have that name, we hit OK, and that will create a mechanical presentation for us with the specific connection that we have just done, that just created. And we will see here and at the bottom, it will be showing the connection as undefined. We double click on that, and we will close this little padlock here. And once you close the padlock, it will change from undefined to revolute. Revolt, as you can see here. You can see the, and then you hit OK. Once you hit OK, you update what you just did, and that will also reflect here on the command. You see that is the revolt has been created. That mm, then the next step will be to check your here on the mechanical manager for the part that the contact that you have created. You wanna update that, so you basically declare the angle connection that you have created. Once you do that, you will see that the command will be showing, command that you have created. So you want to attach a motor to that part, and then you basically attach the motor by right, you do right click on the command. And then it will ask you for the speed if you want to change the speed. It has a pre determined speed, which is the default speed. Let's hit OK. Let's keep the default speed that we want. We update what we just did. Once you have that, so you basically are ready for testing the movement. Uh, you can either just test it directly, or you can come here and check that you have movement on your part. You will see that the mechanism status will be in green. That means that you're okay to go, and you have rotation on your part on the crankshaft. Now you reset all positions back to 0. You will see that there is uh, everything is according to plan. You will check that you have your motor attached to it, to the mechanism, and that will be a good sign just to uh, uh, run the mechanism and see that everything is just running accordingly. So you run it, and that's the first very important step that you want. So you can change the speed just by controlling the speed of mechanism. You stop it and you close it. So we're good to go. Well, for with the second part of the job of the work. In order to attach the rest of components, we go back to assembly design, and we continue with our process of installation. We want to go to ISO view, and we're gonna just basically hide the block, and let's update what we got. Let's hide the block and open the rest of the parts that we have hidden. Rest of the hidden parts. Uh-huh. So let's start with the rods, connection of the rods. The same, just the same procedure. We use the same procedure we were using last time. We with coincide, make it coincide with this uh, part here. And it will ask you if you want to create a connection. You say yes. You go here to first you create your contact with this part here on the crankshaft. Once the contact is created, you wanna verify that everything is just according to plan. You double click on the connection. You check that your padlock is closed, and you have the two axes. You say yes. You say no on the verification, and you update what you just did. Next, you go to the other rod, concentric, over to this one, and then you say yes, you want to create a connection. To this one, and this one here, also in the crankshaft. Double click on that one and check that everything is fine. The padlock is closed. Hit OK. You say no and update. Go to the next one. Same procedure. Oh, well, we made a mistake here. Let's go back. Let's go back to in a position. Let's start from scratch. This one, you say yes. Then next one will be to create a contact. This one, contact has been created. You check your part. You say that everything is just according to plan. Say no. And let's do the last connection. Connection. Same. Same procedure. You say yes. Face. This one. And we'll go to the part. We see that everything is just according to plan. Say okay. Say no. And we update everything. Finally, we do the pistons. Let's close in here. And all the connections done. We move ahead with the piston. Same way. Pistons. Centric. This part. You say yes. You want to create a connection. And in this case, we're gonna try to uh, make coincide these two planes, this plane and this plane. We double check our connection, so that everything is just fine. So no, we update. And that we move to the next one. Centric. This one. Say yes. In this case, we um, make coincide these two planes. We've got the two planes coincided. We check our connection. Everything's just fine. It's good to do this regularly. You can do it at the end, but it's good to do it part by part so you can actually track any mistake that you make. You can have a sequence of all the mistakes that you're making. In case you make a mistake, we humans we make mistakes all the time. So that is very important. Say yes. You want to create a connection. Then you uh, re-strength the bonding by checking the other plane. Double click. Check that everything is fine. Your padlock is closed. You say no. Update. Do the next one. Centric. You want to create connection between this part and this plane and this plane and the plane from the rod. You check the connection engineering connection definition. Everything is fine. Padlock is closed. Say okay, and we update. So once we got that, we'll bring the block. Let's close this. in the block, which has been hidden all this time. We open the block, we bring the block, and we create a connection between this part of the block and the actual piston. Let's say yes. The other one, let's do the same with the other one. Say yes. Update. You always update because in case the system collapse or anything, you don't lose your job, your work. So create concentricity. It's very hard. Sometimes it's fussy. Just get the access. Then please say yes. Was supposed to. Okay, let me do the next one. Electricity. This one. This one. Say yes. And then you go here. Check that everything is just fine. Say no. Go this one here. Same procedure. Check everything's just fine. You're okay. Say no. This one here. And fine. Okay. Say no. On the next one. Same procedure. Okay. Say no. You update everything. 4 connections. Once you have everything updated, then you go back to mechanical design. Put everything nice for you. You go to assembly. Everything in position. Go to mechanical system design. Mechanical system design. You check your management. You verify that the status is in green. Once you have the status in green, and you know that your angle connection is just good. You got the angle with the chest mark. So basically you are good to go. You double check that the parts are moving. All your parts are moving. You reset the values. You don't want everything just looking the way it is. So just basically, so you close here. You can go here to customize view and you hide all the planes and the wires, and so your system will look better when you run it, and you basically are good to go in terms of making your system run. And that's it. That's all about it. This is the way the system can be seen. You can have different views of the system in different positions, and the way I really like the way all the parts move in transparent positions. You can actually visualize the pistons moving. So this is all for today. This is basically what we wanted to show you. You can go back to ISO view and you can close here. This is basically what we have for today. Uh-huh. let's stop the video.